Okay, so the first step is, so we check the boundary conditions. So for the boundary condition, the first thing we check is at the crack surface. And we already know, in this case, we give a guess is Zx. From here we have Zx is equal to sigma x over square root over that. So we check sigma y is equal to real part of Z, and that, of course, based on this, that's where we originally started. So we know this is equal to 0. And tau xy based on this is equal to minus y, real part of C prime, and the y is equal to 0, and that is satisfied. So this is essentially kind of like a circle around, because we already started with this to guess what the stress function is. And if this doesn't satisfy, we must have done something completely wrong. So that should be okay. So the next step, of course, is we need to check at the far away from the crack. So essentially, in this case, your R goes to infinity. So if you look at this, if your R goes to infinity, what can you say about these three vectors? They are pretty much equal, right? They are approximately equal. So that means R1 is approximately equal to R, is approximately equal to R2. And of course the angle also is the same. So now you plug into your sigma x, and so if you look at your sigma x over here, so your theta, did I miss the 2 over here? I think I did. Go back. Yeah. So because there's a square root over here, so that should be divided by 3. Okay, so over here your R and the R1, R2 are equal, so those two cancel out. Sigma 1, sigma 2 is the same, so that term goes to 0. So that sigma x for the first term, as R goes to infinity, that only the sigma left, right? Okay, and then the second term, we have is R sine theta times sigma A squared over R3 over 2 times 2, so that's R3 times sine 3 theta. So over here, this cancel out, so that's become 2. And then if your R goes to infinity, that means that term is going to go to 0, because that's the only one R is there under the is the denominator, so that goes to 0, so that sigma x will equal to sigma. The same thing with sigma y. So your sigma y is the same for the first term. Actually, in this case, sigma x and sigma y is very similar, except one is minus, one is plus. So here you basically have a sigma plus all these terms. And again, as r goes to infinity, the last term goes to 0, so that goes to sigma. And tau xy is equal to so that goes to 0. Okay, so I'm going to stop here. So basically, in this case, what you get is your sigma x is equal to sigma y is equal to sigma tau xy is equal to 0, right? And if we go back to our very beginning, if we have a rectangular, we have sigma x equal to sigma 0, sigma y equal to sigma tau xy equal to 0. So that is satisfied that boundary condition. And if you go convert this to the polar system, then you will get sigma